Question number 19, I think. Okay. Question number 19. Write down. Calculate the end moments. Calculate end moments. Calculate end moments and draw BMD. And draw BMD and draw BMD of given fixed beam of given fixed beam. Okay, so draw diagram. Fixed beam is given. Okay, so draw the diagram. Okay, so this is the fixed beam AB that is given. AB is the fixed beam, and on that AB fixed beam a UDL is acting of 10 kilonewton per meter. UDL is acting okay, having intensity 10 kilonewton per meter. 10 kilonewton per meter. Okay, and 2 point loads are acting. 40 kilonewton is here at a distance of 2 meter from left support, and again 40 kilonewton at a distance of 2 meter. Same. Here is another point load 40 kilonewton again at a distance of 2 meter from point B. These are the points C and D. This point is C, this point is D. C and D, and this distance is again 2 meter. Okay, so this is the given problem. This is what given problem, and you have to solve. You have to solve this problem. Okay. So first thing you tell me whether it is symmetrically loaded or not. First thing you tell me whether it is symmetrically loaded or not. Yes. Symmetrically loaded. Correct? It is what symmetrically loaded. Then start the procedure. If the beam is symmetrically loaded. Yes. Okay. Now see, from figure you can recognize that this given beam is what? Symmetrically loaded, and if the beam is symmetrically loaded, then we can calculate the reactions easily. Very simple task. What is how to calculate the reactions? The total load divided by 2. Whatever the total load coming on that beam, just divide that total load by 2. You will get the reactions. Okay. So start step number 1. Step number 1, solution. Step number 1, what? Calculation of. Now we have written everything in previous problems. Okay. So what you have to write here? Assuming fixed beam. Step number 1. What is step number 1? Assuming fixed beam as a simply supported beam. Find out the support reactions and find the free bending moment values and draw mu diagram. Mu diagram means free BMD. Mu diagram. is also known as free BMD. Is also known as free BMD. Okay, mu diagram is also known as what? Free BMD. So keep this in mind also. Okay, so step number 1, assuming fixed beam as a simply supported beam, draw the diagram. So beam will look like this. We are assuming it as a simply supported beam, but that is exactly not simply supported beam. This is exactly fixed beam. Okay, so original, that is fixed beam. So this is the A point, this is the B point. Again on this AB there is a UDL is acting of 10 kilonewton per meter, and 2 point loads are again acting. This is 40 kilonewton, again this is 40 kilonewton. Okay, and UDL intensity is 10 kilonewton per meter, 10 kilonewton per meter. And again distances have given, this point is C, this point is D. So this distance is 2 meter, this distance is again 2 meter, and again this distance is 2 meter. And these are the reactions. These are the reactions of simply supported beams. VA and VB are the reactions of what? Are the reactions of simply supported beam. Okay, now find out VA and VB. So I have told you what? If the beam is symmetrically loaded, then it is very easy task to calculate the support reactions. When beam is symmetrically loaded, then there is no need to apply the algebraic equations like summation moment, summation Fy. No need. You can directly calculate the support reactions. What is the formula? Therefore, VA is equal to VB is equal to what? Total load divided by 2. Total load divided by 2. So what is the total load? This 40 kilonewton point load is there. Okay. Okay. So this 40 kilonewton point load is there. Plus again this 40 kilonewton point load is there. Plus now convert this UDL to point load. Convert this UDL to point load. How to convert? 10 into distance. On whole span the UDL is spreaded. So 10 into 2, 4, 6. So 10 into 6. I will write like this. 10 into 6. This is the point load. We have converted this UDL to point load divided by 2. So what is the value of VA and VB? VA is equal to VB is equal to, find out the answer. VA is equal to VB. This answer is 40, 40 plus 80 plus 60 means 140 divided by 2 means 70 kilonewton. Check this answer. Is it correct? 70 kilonewton. Is it correct? Yes, correct. Yes, good. Monica and Sanjana. Correct answers. Yes, correct answer, Mandar. Okay, so VA is what? VA and VB both will be the same. Now see here. See here. What will be the reactions of fixed beam? RA and RB. इथंच क्लिअर करतो मी, लक्ष द्या बघा. What will be the values of RA and RB? So I have given you one important note. What is that note? If beam is symmetrically loaded, then what? Support reactions of simply supported beam and support reactions of fixed beam are always same. There is no change in the support reactions of the simply supported beam and the support reactions of the fixed beam. RA and RB are the support reactions of fixed beam, and VA and VB are the support reactions of simply supported beam. So that already we have discussed in previous so many lectures. Okay, so RA and RB will be same as that of VA and VB. This condition is applicable to only those beams which are symmetrically loaded. This condition is not applicable to all the beams. This condition is applicable to only those beams which are symmetrically loaded, which are symmetrically loaded. Clear? So that step we have to skip to calculate the R and RB. Okay. So problem become much easier if it is the symmetrically loaded. Okay, very much easy problem if it is symmetrically loaded. So VA and VB we have got. Now find out the support reactions. Sorry, free bending moment at C and D. Now there is no shortcut formula to calculate the free bending moment at C and D. You have to take section there, and then you have to calculate the bending moment at free bending moment at C and D point. Free bending moment at C and free bending moment at D. So याचा काही shortcut formula आपल्याकडे available नाहीये. That's why you have to take a section there and then consider left part of that section or either right part of that section, and then you will get the free bending moment at C. Now see here. Now see here. Here we have to consider section, and we have to consider the left part of that section to calculate the free bending moment at C. To calculate the free bending moment at that C. Clear? Now see here. Here is the section, and consider the left part. No, not here. You have to consider section in this beam, simply supported beam. Okay. Now consider the left part. VA and VB. We know the values. VA, VB are 70. This is 70. This is 70 kilonewton. 70 kilonewton. 70 kilonewton. Now, if we consider a section like this, and draw, if we consider the left part of this section, suppose this section is x1, or at point C, we can say it as at point C. Okay. Now see, this is the beam. On the left part of section we have considered. This is VA 70. This point is C point, and this is the UDL. Up on portion A to C, this is the UDL of intensity 10 kilonewton per meter, and this distance is 2 meter. Okay, clear? We have considered the left part of that section, what we have taken. Okay, now find the bending moment at C. Free bending moment at C. For free bending moment, we denote it by small m. Small mc is equal to, what is the equation? If force is going upward, then it is creating sagging bending moment. Sagging means it is positive. So if it is going upward, then we have to consider sagging. So 70 into 2. 70 into 2. Next. Now this UDL is acting in the downward direction, means it is creating hogging bending moment. It is creating what? Hogging bending moment. So hogging means we have to consider it as a minus. So minus, and you have to apply trick. मी तुम्हाला ट्रिक ऑलरेडी सांगितलं, UDL असेल आणि जर बेंडिंग मोमेंट काढणार असाल तर काय ट्रिक तुम्हाला मी सांगितली? -10. What is the trick you have to apply for UDL? -10 into 2. This is the distance. Make square of that distance and divide it by 2. Find out the value of free bending moment at C. Yes, find out the value of free bending moment at C. Find out what is the value. So that is the equation, and tell me the answer. Yes. Answer is 120. Just wait. Answer is 120 kilonewton meter. Correct answer. Mandar, Sanjana, Monica, and Sonal. Correct answers. 120 kilonewton meter is the answer. Correct. Clear? How to calculate? Is it clear? I think this is clear to all because we have solved so many problems regarding this and you are very much aware about this. Okay. Now similarly you have to consider section here. Now similarly you have to consider section at D like this and you have to consider the right part. So suppose if we want to select the left part, okay, you can select the left part also of this section, but you have to do more calculations. Answer will be same. Answer तुमचं तेच येणार आहे पण तुम्हाला जर कोण म्हणलं सर आम्ही सेक्शनची डावी बाजू कन्सिडर करणार आहे करा काय प्रॉब्लेम नाही फक्त कॅल्क्युलेशन तुमचे वाढतील आन्सर मात्र तेच येणार आहे लक्षात येते आन्सर मात्र तेच येणार आहे काय फरक पडणार नाही सो मी काय करणार आहे राईट पोर्शन घेणार आहे सो दिस इज द सेक्शन and this is the right beam. This is the right portion of beam of this section. Here it is 70. Okay, and again UDL. So see, as it is symmetrically loaded, free bending moment at C and D both will be same. As it is symmetrically loaded, so many things will become easy. Free bending moment at C and D will be same. काही बदल येणार नाही त्याच्यामध्ये बघा करून बघा तुम्ही you can calculate also. So free bending moment at D, this is the 10 kilonewton per meter. Okay, so free bending moment at D is equal to, what is the value again? 70 into this distance is 2 meter. This is B. So 70 into 2 minus 10 into 2 square divided by 2. Same equation you will get like this. Same equation. So answer will be again same. Of course that answer should be same because it is symmetrically loaded. So free bending moment at C and D should be same. So free bending moment at D answer is again 120 kilonewton meter. 120 kilonewton meter. Okay, now draw free BMD. Now draw free BMD. Okay, now draw free BMD. See here, this is the A point. This is the A point. Again, this is the C point. This is the D point. And this is the B point. Okay. Now free BMD is what? Parabolic because UDL is acting over the entire span. So free BMD will be parabolic like this. Free BMD will be like this, parabolic. Okay, free BMD will be like this, parabolic, and the values at C and D will be same. What? 120 because it is symmetrically loaded. 120, 120. This is positive. Whole diagram is the positive diagram. And this bending moment diagram is called as a mu diagram. This is called as what? Mu diagram. Okay. Next. Now what is our step? Step number 2. Step number 2, calculation of fixed end moments. Yes. Now that part is very interesting. Step number 2, calculation of fixed end moments. Calculation of fixed end moments. Now for that you have to consider 3 formulae. Okay. Now see here. This is the small w. For UDL you have to consider small w. Just wait. See here. This is what small w. Okay. This is what w1. This is what w2. This is w1 40. W2 is 40. Small w is 10. A1 is what? A1 is this much distance. That is 2 meter. A1 is 2 meter. Okay. And A2 is remaining distance. Sorry, B1. A1 is 2 meter and B1 is remaining distance. B1 is what? 4. B1 is what? 4. A1 2 meter, B1 is 4 meter and W1 is 40 kilonewton. Similarly, this W2 means A2, W2. This is 40 kilonewton and A2 is this much distance. Left side distance 4 meter. A2 is equal to 4 meter. B2 is equal to 2 meter. And W2 is equal to 40 kilonewton. And small w is 10 kilonewton per meter. Small w is 10 kilonewton per meter. Now for this, capital MA and capital MB both will be same. Here is the fixed end moment capital MA and here is the fixed end moment capital MB. For this case, for this symmetrically loaded beam, capital MA and capital MB means fixed end moments will have same value. Will have same values. Therefore, capital MA is equal to capital MB is equal to, what is the formula due to UDL? Formula due to UDL is minus WL square upon 12. Next, minus for this W1, minus W1 A1 B1 square upon L square, minus W1 A1 B1 square upon L square, minus again for this W2 A2 B2 square upon L square. Same formula you have to apply, minus W2 A2 B2 square upon L square. Now put the values here and find out the values of capital MA and capital MB, means fixed end moments. Find out the answers. Put the values there. What is W? It is 10. So minus 10 into L is the 246. 6 square upon 12. Minus W1 is again 40 into A1 is 2. B1 is 4 square upon 246, 6 square, minus W2. W2 is again 40 and A2 is 4 and B2 is 2 square upon L is again 6 square. Now put these values in your calc and find out the answer. Find out the answers of MA and MB. Yes. Find out the answer of MA and MB. Find out the answer of capital MA and capital MB. Put the values and tell me the answer. MA and MB will be same this time because it is symmetrically loaded. So in exam, keep in mind 83.33, that is correct answer. Monica, Sanjana and Sonal, correct answer. So MA and MB both will be same both will be having same magnitude, that is minus 83.33 kilonewton meter. Minus sign indicates it is hogging in nature. Minus sign indicates it is hogging in nature. So this is MA and MB. Okay, MA and MB. We have got the values minus 83.33. Next, third step. चला कोणाचा आन्सर मॅच झालं नाही असं कोण आहे का? MA चा आन्सर वेगळा आलाय असं कोण आहे? बोला. minus 83.33 kilonewton meter. This is the correct answer. Good. Okay. Now what is our next step? Next step is to calculate the support reactions of fixed beam. Next step is to calculate the support reactions of fixed beam. Fixed beam support reactions of fixed beam means what? RA and RB. But for this problem, there is no need to calculate RA and RB like previous problems, because this is symmetrically loaded. If the beam is symmetrically loaded, then VA and RA are same, VB and RB are the same. So for that purpose, right here, due to symmetrically loaded beam, support reactions of simply supported beam, SSB, support reactions of simply supported beam, SSB, and fixed beam will be same. Therefore, RA is equal to VA is equal to, what is the VA? That is 70. That is 70 kilonewton, means RA is 70 kilonewton. Next, RB means RA is what? 70 kilonewton. This is RA. Next, similarly, RB is equal to VB is equal to again 70 kilonewton, and RB is equal to what? Same, 70 kilonewton. Okay, RB is 70 kilonewton. See, if you have to calculate the capital R, like previous problem, what is the formula to calculate capital R only? MA, or you have to subtract the smaller moment from bigger moment. Now this time MA and MB both are same. What we have done? MA minus MB upon L, or MB minus MA upon L. That is depends upon the magnitude of moment. Now this time MA and MB both are same. So this will become 0. This will become 0. So there is no effect of moments when moments are same. When fixed end moments are same, then there is no effect on support reactions. Okay, so that's why RA and VA both will be same, RB and VB both will be the having same values. Clear? So we have got the values of RA and RB, and these are the RA and RB are the support reactions of the fixed beam, right? Support reactions of fixed beam. Now see here, now draw mu dash diagram. So that will be rectangle, na? That will be rectangle, because MA and MB both are same, minus 83.33. That diagram we have to draw the below the baseline. If it is minus, we always draw below the baseline, but we have to superimpose that mu dash diagram over this mu diagram. That's why we will draw that diagram above the baseline. Simple. So that already we have discussed. So minus 83.33 means like this rectangle. you will get rectangle like this. Okay, you will get rectangle like this, and this value is where is that value? Minus 83.33. So this is what I will show it by different color. Just wait. Okay, now this is what 83.33 negative, and this is 83.33 negative, and this whole diagram is net BMD. This whole diagram is what? Net BMD. Okay, this whole diagram is what? Net BMD. Now again there are two point of contraflexures. This one is the point of contraflexure. This one is the point of contraflexure E. Okay, and again this one is the point of contraflexure F. So from this diagram you can calculate net bending moment at C easily. From this diagram, from this net BMD, this is what net BMD diagram, net bending moment diagram. Okay, you can easily calculate net bending moment at C. So tell me what is the value of net bending moment at C. Net bending moment at C ची काय व्हॅल्यू असेल या डायग्राम म्हणून मला सांगा तुम्ही. Yes, what will be the value of net bending moment at C? तुम्हाला सेक्शन घ्यायची गरज नाही. प्रॅक्टिस साठी घेणार असाल तर सेक्शन घेऊन तुम्ही बघू शकता. आन्सर तुमचं सेम येणार. पॉइंट मध्ये थोडासा फरक पडेल. So what is the value of this net bending moment at C? Yes. Net bending moment at C. What will be the value? सांगा बरं कसं काढणार? मायनस कसे येणार? 36.67 correct. 36.67 correct answer. Correct answer. Good. Monica, Vaishnavi, Sonal and Mrunal. Correct answer. Okay, how to calculate net bending moment at this point? From mu diagram, subtract this value. Means 120 minus 83.33. Answer is 36.67. Correct answer. 36.67. This is the, again this will be same. This is also net bending moment at D. This is what? Net bending moment. Net bending moment at F. Sorry, D na? At D. At D. And this value is again same. 36.67 kilonewton meter. Okay. Finish. ठीक है? You can hatch this common portion also. You can hatch this common portion also if you want. Okay. Now, so this is our step. Okay. Now we have drawn the mu diagram, everything. Now you have to calculate the position of point of contraflexures. Now you have to calculate position of point of contraflexures. Position of point of contraflexures means you have to again consider the section. Means you have to again consider the section at point E. And at that point you have to show, or you have to calculate, you have to show the value of bending moment 0, or you have to equate that value of bending moment to 0. Again you consider the section at F. Again if you consider the section at F, no need to consider the section at F, because as it is symmetrically loaded, whatever the distance of E, that same distance F will be there from B. Symmetrically loaded आहे ना, त्यामुळे हे जे distance आहे, suppose this distance is x1. Suppose we are assuming that this point of contraflexure E is at a distance of x1 meter from point A, and F point of contraflexure is at a distance of x2 from point B. Then as this beam is symmetrically loaded, this x1 and x2 will be having same values. You can calculate. Okay. Now for that we have to consider section. Before that we have to draw a free bending moment, FBD, free body diagram of the fixed beam. Here it is, free body diagram of fixed beam. Just write the values there. What is MA? 83.33. Write down there. Also here 83.33. Remaining all the values are there. Okay. No. Just replace this. Fixed support by reactions. Okay. Now here will be the reaction. RA means support reaction. RA means what? Support reactions of fixed beam, and RB. Okay. RA and RB 70. So here it is 70 kilonewton. RB is also 70 kilonewton, and UDL is acting. So this is the FBD, free body diagram of. This is the FBD of free body diagram of the fixed beam. Now again we have to consider section in between A and C, and then we have to find out the value of position of or distance of point of contraflexure. See here, this is the free body diagram of FBD. Free body diagram. This is what FBD of fixed beam. FBD of fixed beam. Okay. Now consider the section. Now consider the section in between A and C, because that point of contraflexure is located in between A and C. That's why we are considering the section in between A and C. See here, this is the location of point of contraflexure, but we don't know the exact distance. That's why we are considering the section there, and we know that at point of contraflexure the bending moment value is always 0. So by considering this section in between A and C, we are assuming the distance is x1. This section x1 is at a distance of x1 meter from A, and that point is what? F, na? I think E point. That point is E. Okay. That point is what? E point. Now draw the left portion of this beam of that section. Now this is the section we have considered. Okay. Now consider the left part. This is the reaction RA 70 kilonewton. Next, this is what MA, fixed end moment, that is 83.33, and UDL is acting. Okay. UDL is acting having intensity 10 kilonewton per meter, and this point is A, this point is E, means point of contraflexure. Okay, and this distance is x1. This section is x1. and this distance is x1, that we have to find out. And we know that point is point of contraflexure, and at point of contraflexure the bending moment is 0. Now calculate the equation at this section and equate that equation to 0. You will get x1. So what will be the equation? Is there anyone who have calculated the answer, who have find out the answer? Is there anyone who have find out the answer? See, this type of problems we have solved in previous lectures also. So you should be aware about this process. So this is again going upward. If it is going upward, it is creating sagging bending moment. Bending moment at E is equal to 0. Why 0? Because at point of contraflexure bending moment is always 0. Okay. So prepare equation. This 70 is going upward. 70 into x1. 70 into x1. It is going upward. Sagging. Sagging means plus. Next, this is this will we will take later on. This, what about this UDL minus 10 into, what is the trick? If it is UDL, then take the distance, make the square of it, divided by 2. Again this moment, again it is hogging bending moment. We have to consider it as a minus 83.33. Don't multiply this moment by distance. This is already moment. No need to multiply by distance. So this is the equation. Is there anyone who have calculated the answer? What is the value of x1? Yes. Now transfer all these values to the right side. So minus 10 upon 2 means 5. If we transfer this value to the right side, so that will become 5x1 square. That will become positive. Next, this is 70x1. It is plus on left side. If we transfer this value to the right side, that will become minus 70x1. So minus 70x1, and this will become plus on the right side. Plus 83.33 is equal to 0. Again, you have to compare it with ax square plus bx plus c, quadratic equation. Okay, 1.127 meter is the answer. Let me check. Okay, let me check. What is the answer? 1.127. 1.12. Check the answer. Check the answer once again. Compare it with ax square plus bx plus c. A is equal to what? 5. B is equal to what? Minus 70. And c is equal to minus 83.33. Now find out x1. Now find out the x1. So x1 will be, therefore x1 is equal to what? Minus b plus or minus under root b square minus 4ac upon 2a. Now put the values here. Minus, and b is already minus. So minus of 70 plus or minus under root minus 70 square minus 4 into a is 5, c is 83.33 upon 2 into a is 5. Okay, so first put plus sign here and then put minus sign here. You will get two answers. You will get two answers of x1. So tell me the answers of x1. Tell me both answers. Tell me both answers. Yes. What is the answer of x1? Please cross check it. Monica. Oh. 12.68 meter. If you put the plus there, if you put plus here, you will get 12.68 meter. Or what is another answer? If you put minus instead of plus, you will get another answer of x1, that is 1.31. Yes, that is the correct answer. 1.31 or 1.32. 1.32 or 1.32 meter. So which one we have to consider? See, total span of beam is 6 meter. Total span of beam is 6 meter. So 12.68 meter is not valid. This is not valid. Therefore, x1 is equal to what? 1.32 meter or 31 meter. What is the answer? And that should be less than 2 meter. AC मध्ये ना ते. So 1.32 meter हे 2 पेक्षा कमी यायला पाहिजे. So आलेला आपला answer. So this is what? x1. This is x1. Okay. This is what x1. Finish. Clear? Similarly, you can calculate x2 also. Similarly, you can calculate x2 also. Same equation you will get, same answer you will get, because it is symmetrically loaded. मोनिका काय चुकलेलं बघितलं का? Yes, correct answers. Purva, Monica, Mandar, Vaishnavi. Okay. So काय चुकलं होतं बघितलं का? ठीक है. So this was our last problem. This was our last problem from this topic. Okay, from the topic fixed beam. Clear? Okay. 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 So we have covered all the types. We have covered all the types. First type we have seen, that is the equation problems based on first principle equations. Problems based on first principle equation. What is the first principle equation? Two equations are there. What are they? MA plus MB. MA plus MB is equal to minus 2A upon L. And second equation, MA plus MB equal to minus 6AX bar upon L square. Okay, minus 6AX bar upon L square. So these are the first principle equations. And by using this first principle equation, if in question they have mentioned that find out the fixed end moments by using first principle equation, then compulsory you have to use these equations. Compulsory you have to find out the fixed end moments by using these first principle equations, right? If not mentioned, then process what we have used in previous problem, that you have to adopt. Okay. And one more thing is, we have seen see here, we have seen, just wait, the formula. We have seen the formula that you have to keep in mind. That list, just wait. Okay, see here. These are the first principle equations. MA plus MB equal to minus 2A upon L, and MA plus 2MB is equal to minus 6X bar upon L. Fixed end moments by using first principle. That also we have solved. Then this table is most important. These three cases are very very important. हे तुम्हाला 3 केसेस पुढच्या टॉपिकला पण लागणार आहेत. जो आपण आता थर्ड टॉपिक चालू करणार आहे कंटिन्युअस बीम, त्याला पण लागणार आहे चौथा टॉपिक मोमेंट डिस्ट्रीब्युशन मेथड, त्याला सुद्धा लागणार आहे. ओके, सो दिस इज द केस नंबर 1, फिक्स्ड बीम कॅरिंग सेंट्रल पॉइंट लोड. What is the formula of free bending moment? How to calculate free bending moment? We have to consider the fixed beam as a simply supported beam, and then we have to calculate the fixed end moments. Now, if we consider simply supported beam, as A and B are simple supported, free bending moment at A and B are always zero. Are always what? Zero. Free bending moment at C, that is plus WL by 4. I have shown the derivation of that also. तुम्हाला मी त्याचं डेरिवेशन पण दाखवलं होतं की WL by 4 कसं आलं. What is the value of fixed end moments for this case? MA and MB, this time both will be same because it is symmetrically loaded. So MA and MB both will be same, negative in nature because they are hogging, creating hogging bending moment, that is minus WL by 8. Fixed beam carrying UDL, free bending moment at C is WL square by 8. Free bending moment is always positive. Free bending moment diagram is always positive and it is also known as a mu diagram. Okay, and fixed end moments for this case is minus WL square upon 12. Negative sign indicates it is hogging in nature. Right? Now, third case, it is eccentrically loaded. This is not symmetrically loaded. W is acting at a distance of A meter from left support and B meter from right support. For this, free bending moment at C is WAB upon L. Free bending moment is always positive, and it is denoted by small m letter. Okay, and capital MA, capital MB, both are different this time because it is symmetrically loaded. Capital MA is what? Minus WAB square upon L square, and capital MB is different. Capital MB is minus WA square B upon L square. Okay, सो हा टेबल आपल्याला लागणार आहे नेक्स्ट टॉपिक्सला पण लागणार आहे. म्हणजे हा टॉपिक संपला आणि हा टेबल आता मी विसरतो असं चालणार नाही, तुम्हाला हा नेक्स्ट टॉपिकला पण लागणार आहे. ओके, ठीक.